Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL May 2021 paper 1 time zone 2 past paper. And today we will be solving the question number 11 from section B of this paper. You will be getting the links to all the previously solved questions of this paper and also from the other papers in the description area in form of playlists. So without any further delay, let us start solving this question number 11. The maximum mark is 20. I have just brought in the subpart A. We will be solving each subpart one at a time. And actually, there are 5 subparts to this question. And the question says the acceleration a meter per second square of a particle moving in a horizontal line at time t seconds, where t is greater than or equal to 0, definitely, is given by a equal to negative of 1 plus v, where v meter per second is the particle's velocity and v is greater than negative 1. At time t equal to 0, the particle is at a fixed origin O. That means the displacement, I'm not sure whether we will be needing the displacement or not, but at time t equal to 0, the displacement is equal to 0 and the initial velocity is v0 meter per second. Okay. Subpart A, the question is by solving an appropriate differential equation, so that the particle's velocity at time t is given by v of t equal to 1 plus v0 or v0 times e to the power of negative t minus 1, and this is containing 6 marks. We have to form a differential equation and we have to solve the differential equation, plain and simple. And what differential equation can we form? What will be the equation that we will be taking? We are at present having only a single equation. A equal to negative of 1 plus v, so we will be taking this. So, A is equal to negative 1 plus v. And we have to get the expression for the velocity. We are having the expression for the acceleration. So what is acceleration? It is the rate of change of velocity. So I can write this as dv dt equal to negative 1 plus v. Okay. And now since we have to form a differential equation, I bring the 1 plus v part to the left side. How do I bring it? I divide the entire equation by 1 plus v. Okay. So I can write this to be equal to, this implies 1 over 1 plus v dv dt is equal to negative 1. Okay. And now I will be integrating both sides with respect to t. So I am integrating the left side with respect to t. And also I am integrating the right side with respect to t. I am keeping the minus 1 outside the integration sign because it is a constant. Okay. So these two will be getting cancelled and what we will be having is this 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is equal to negative integration of dt. So 1 over 1 plus v dv is 1 over 1 plus v, if we integrate this with respect to v, we get ln of 1 plus v. Okay. If you are not sure, you be, okay, let me just show you how am I getting this if you are not sure about the integration result. And if I write let t is equal to 1 plus v, okay, then what will dt dv be equal to? Dt dv will be equal to 1, because if we differentiate both sides with respect to v, we will be having dt dv on the left side, and derivative of 1 is a constant, will be 0, and the derivative of v with respect to v is 1. So that means dt is equal to dv. Okay. And therefore, 1 over 1 plus v dv can be written as 1 over t. In place of 1 plus v, I am writing t. And in place of dv, I am writing dt. And we know 1 over t, if we integrate 1 over x with respect to x, it is ln of x. If we integrate 1 over t with respect to t, it will be ln of t. And what is t? T is 1 plus v. So that is how I am getting ln of 1 plus v modulus equal to minus t plus c. Don't forget the constant of integration. Okay. And then what do? We find the value of the constant of integration if possible. Over here, they have given us some information. Let us use those information and let us try to get the value of c. They are saying at time t equal to 0, the velocity is v0. Okay. So, at t equal to 0, it is ln of 1 plus v0 equal to minus 0 plus c. And that means c is equal to, therefore c is equal to ln of 1 plus v0 modulus. Okay. So, I can write this equation as, this is maybe equation number A. Therefore, equation A is ln of 1 plus v modulus equal to negative t plus ln of 1 plus v0. Okay. And I'm having one ln term on the left side, one ln term on the right side. So let us have both the ln terms on one side, that is maybe the left side. So I can write this as ln of 1 plus v modulus minus ln of 1 plus v0 is equal to negative t. So ln of 1 plus v over 1 plus v0 is equal to negative t. Now we will be converting this logarithmic equation to an exponential equation, because we are not having any logarithmic term in the equation that they have given us. So this will be equal to e to the power of negative t. Okay. And I have to get the expression for expression of v in terms, v is a function of t. So I have to get v equal to something. So let us see what expression do we get for v. First of all, let us multiply both the sides by 1 plus vc. So we get 1 plus v equal to 1 plus v0 times e to the power of negative t. Okay, or phi, which is a function of t, should be equal to 1 plus v0 e to the power of negative t minus 1. Let us see if we were given the same equation or not. 1 plus v0 e to the power times e to the power of negative t minus 1. Okay, so it is 1 plus v0 times e to the power of negative t minus 1. Okay, so we have shown this. And how many marks does this contain? 6 or 7? 6 marks. We have got 6 marks. Okay. Now we move on to the subpart B. Now coming to subpart B, it is containing 2 further subparts and it is containing a total mark of 7. And you have seen the subpart A was containing 6 marks and we have got those 6 marks. I'm just mentioning this repeatedly just to show you that these are completely doable questions, because I know students, they have phobia about these section B questions. Of course, section B questions do contain many subparts. So you will be needing some more time to solve the the section B questions as compared to the section A question. So you have to just distribute your time in that way. When you practice the questions before the examination, you have to practice in that way so that you solve the section A questions faster. Okay, because for section B, you will be first of all having many subparts in a single question, and you may need to think a bit for answering the questions. So the section A questions should be answered and reject as fast as possible. Okay. So coming to subpart B, and it says initially at O, the particle moves in the positive direction. So maybe it is, this is O point. The particle is moving in the positive direction until it reaches its maximum displacement from O. Maybe this is the maximum displacement from O, and then the particle then returns to O. Then the particle returns to O. This is the motion diagram of the particle. Okay. And let S meters represent the particle's displacement from O, and S max its maximum displacement from O. So this whole thing is S max. The part I show that the time capital T taken for the particle to reach S max satisfies the equation e to the power of capital T equal to 1 plus V0. And this is the equation for V that we have shown in subpart A. Okay. So S max, after the particle comes to this S max, the maximum displacement, it just turns and it goes to the initial position, the original position. It returns back to its original position. So, and this S max is occurring when the time is capital T, seconds. Okay. So, at this time t equal to capital T seconds, the particle is turning. Hence, the v of t, capital T, should be equal to 0. Okay, because at this moment the particle is turning, so momentarily the particle is at rest. Fine. So we will be taking this equation, that v of capital T is equal to 0. We will be substituting capital T in this equation. Okay. So let us just write the equation once more over here. V of t is equal to 1 plus V0 e to the power of negative t minus 1. Okay. And V of capital T is equal to 0. So what is V of capital T? This is equal to 1 plus V0 e to the power of negative capital T minus 1. This is equal to 0. Okay. So 1 plus V0 whole multiplied by e to the power of negative capital T is equal to 1. And if we divide both sides by e to the power of negative t, we get what? 1 plus V0 equal to 1 over e to the power of negative capital T. And 1 of e to the power of negative capital T is 1 over e to the power of positive capital T. So 1 over e to the power of positive capital T, this is equal to e to the power of positive capital T. Okay? And what do we have to show? E to the power of positive capital T equal to 1 plus V0. Fine, we have come to this step. Therefore, e to the power of positive capital T is equal to 1 plus V0. Sure. Okay. This was subpart I, and now coming to subpart I, which says, by solving an appropriate differential equation, again another differential equation we have to solve, and using the result from part BI, that is this one, that is the result is e to the power of positive capital T is 1 plus V0. Find an expression for S max in terms of V0. So we have the expression of V, we need the expression for the displacement. What is velocity? It is the rate of change of the displacement with respect to time. So V of t will be ds dt. Okay. So we write this. Start over here. I hope you are being able to see. I'm just copying the expression and then I'll be scrolling. E to the power of negative t minus 1, and we are required to get the expression for S max in terms of V0. And S max will be happening when time t equal to capital T. So first of all, let us write this V of t as ds dt. Okay. So ds dt equal to 1 plus V0. Now V0 is a constant, is a number, it is a constant. The velocity at time t equal to 0. So 1 plus V0 is a constant. It is the coefficient of e to the power of negative t. Then answer. Okay. So this is 1 plus v0 times e to the power of negative t minus 1. And now we integrate both sides with respect to t. So I can just keep 1 plus v0 outside because it is a constant. E to the power of negative t dt minus 1, I am not writing 1 explicitly, dt. Okay. So these two will be getting cancelled. So we are having s equal to 1 plus v0 and e to the power of negative t when integrated with respect to t will be giving us minus e to the power of negative t, and this is minus t plus c. Okay. And we next what do? We always get the value of the constant if possible. So constant of integration, that is c. So can we get the value of constant of integration? Let us see what all information has been given to us. At time t equal to 0, the particle is at a fixed origin O. That means the s equal to 0. That is what I had written at the very beginning. At t equal to 0, s is 0. Okay. So now we will be using this information and I will be writing 0 over here. 1 plus v0. I can take the minus sign in front. E to the power of 0. Negative 0 is 0. Minus 0 plus c. E to the power of 0 is 1. And minus 0. So c will be basically equal to 1 plus v0. Okay. Therefore, s is equal to 1 plus v0, negative in front, e to the power of negative t minus t plus 1 plus v0. Okay. So this is the expression for s. Now we want to have the expression for s max. And S max will happen when the time is equal to capital T. When T equal to capital T, S is equal to S max. Okay. So, therefore, S max is equal to negative 1 plus V0 e to the power of negative capital T minus capital T plus 1 plus V0. Okay. And now they are saying, what is the question? Let us read the question once more. Find an expression for S max in terms of V0. They did not say in terms of capital T. So we have to, and they have also said that you will be using the result from the part BI. So what was the result of part BI? It was e to the power of capital T was equal to 1 plus V0. We will be substituting this. In place of e to the power of positive capital T, we will be writing 1 plus V0. Okay. So this can be written as negative 1 plus V0 It is e to the power of negative to t, so negative capital T. So I can write this as over e to the power of positive capital T. Okay. And since e to the power of positive capital T is equal to 1 plus V0, therefore capital T is equal to ln of 1 plus V0. Okay. So we will be writing that. Let me write minus T over here for this step. This is S max is equal to negative 1 plus V0 over e to the power of capital T was equal to 1 plus V0. So in place of e to the power of capital T, we will be writing 1 plus V0. And in place of capital T, simple just capital T, we will be writing ln of 1 plus V0. So this is ln of 1 plus V0 plus 1 plus V0. And these two will be getting cancelled. So this is minus 1 and that will be plus 1. So let me rewrite this once more. This is minus 1 minus ln of 1 plus V0 plus 1 plus V0. These two will be getting cancelled. So we have S max equal to V0 minus ln of 1 plus V0. Okay. So we have given them the expression for S max and we have got 7 marks. Okay. So this is, I'm not saying it is very easy, but it is doable. And it is not extremely difficult as well. It is doable and it is not very easy, not a trivial question, but it is not extraordinarily difficult as well. Okay, that is what I am trying to make you realize, because I'm just trying to uh, take you out of this phobia that the section B questions are practically undoable and it takes quite a lot of time. Yes, it does take quite a lot of time to solve a single question of section B because it contains several subparts, but you should be having that time. That is how you should be preparing yourself to answer the section A questions fast and to recheck them as well fast, so that you have sufficient time to give to the section B questions. Okay. So we are done with this subpart B. Move on to the subpart C. So subpart C. Let V of capital T minus k represent the particle's velocity k seconds before it reaches S max. It is reaching S max at capital T, time t equal to capital T, but it is k seconds before the capital T, so it is T minus k, where V of T minus k equal to 1 plus V0 whole multiplied by e to the power of negative T minus k minus 1. It has to be, it was e to the power of negative small t. In place of small t, they have substituted capital T minus k minus 1. And the question is, by using the result to subpart B, I this is the result to subpart B. I of capital T equal to 1 plus V0. Show that V of T minus K equal to K e to the power of K minus 1. And it is containing just 2 parts. So let us write the expression first of all. So this is 1 plus V0. And I'm separating because I need e to the power of T. So I'm separating. It is e to the power of negative T, capital T, times e to the power of K minus 1. So this is e to the power of negative T. So I can bring this down. It is 1 plus V0 over e to the power of capital T times e to the power of K minus 1. And in place of e to the power of capital T, I'll be writing 1 plus V0. So it is 1 plus V0 over 1 plus V0 times e to the power of K minus 1. So these two will be cancelling. Therefore, V of T minus capital T minus K is equal to e to the power of K minus 1. Shown. Okay. So we have completed subpart C. Moving on to subpart D. Similarly, let V of T plus K represent the particle's velocity k seconds after it reaches S max. And the question for this subpart D is deduce a similar expression for V of capital T plus K in terms of K. Again containing 2 marks, and V of capital T minus K given in subpart C was having this expression. So similarly means we have to use a similar expression in place of capital T minus K, we will be having capital T plus K. That is the difference. And in the original expression, it was V of small t, and in place of T plus K or T minus K, it was e to the power of negative small t. So we will be just substituting. We will be writing V of capital T plus K is equal to, from subpart C, we get, let me write this in the next line because we will be having some subscripts. V of capital T plus K is equal to 1 plus V0 e to the power of negative capital T plus K minus 1. And this is, again, I'll be separating e to the power of negative capital T times e to the power of negative K minus 1. So, V of capital T plus K is equal to 1 plus V0 over e to the power of capital T times e to the power of negative K minus 1. And what is e to the power of capital T? It is 1 plus V0. So, V of capital T plus K is equal to 1 plus V0 over 1 plus V0 times e to the power of negative K minus 1. and these two will be cancelling each other. So the V of capital T plus K will be equal to e to the power of negative K minus 1. E to the V of capital T minus K was equal to e to the power of positive K minus 1, and this is V of capital T plus K. So this is equal to e to the power of minus K minus 1. Okay. So deduce a similar expression we have deduced, and this is question, the subpart D. We have completely solved the subpart D of this question number 11. So let us move on to the last subpart, that is subpart E. Subpart E. Hence show that V of capital T minus K plus V of capital T plus K is greater than or equal to 0, and it is containing 3 marks. We are having the expressions for these two. So we can just write V of capital T minus K plus V of capital T plus K. This is equal to e to the power of K minus 1 plus e to the power of minus K minus 1. So this is e to the power of K plus e to the power of negative K minus 2. And this should be shown to be greater than or equal to 0. Whenever you have this type of a question that you have to show that some expression is greater than or equal to 0, the best way is to go for the completion of the square method. See, if you have something, if you can express that expression in form of something whole square plus a positive quantity. The whole square part has to be a positive number plus some other positive number. Therefore, the expression will be a positive number. So this is the best way to prove that the given expression is a positive number or equal to 0. Okay, so we will be using that method. We will be trying to get it or express this in form of something squared. We may have some portion outside, some number outside the whole square part, but we will be trying to write this as something whole square. Okay. For getting something whole square, we have to first of all think of how to write these as some whole square in the form of something whole square. So I can write this as e to the power of k over 2 whole square, and e to the power of minus k is 1 over e to the power of k. So this can be, if the minus sign is just bothering you, bring it down. E to the power of k over 2 whole square, and I'm having minus 2. So if I write this as minus 2 times, this is minus 2 means minus 2 times 1. So can I write this as minus 2 times e to the power of k over 2 times 1 over e to the power of k over 2? Because these two will be cancelling and we will be getting a 1, which is minus 2 times 1, that is minus 2. So we can write this expression in form of this expression. Okay. And this is nothing but a minus b whole square. A square plus b square minus 2 times a times b. So this is equal to e to the power of k over 2 minus 1 over e to the power of k over 2 whole square, which should be a positive number or equal to 0. Okay. proved. Hence showed. Okay, hence show. So let me write hence show. Okay. Always, whenever you have to prove that some expression is greater than or equal to 0, you try to express that expression in term of some like completion of square. Okay, there should be some square part and there will be some additional number added to that. Maybe there will be some additional number. Over here, we are not having such additional number, but there may be cases where you will be having some additional number in addition to the whole square part. So they are just added together. The whole square will be a positive number or equal to 0 plus a non-zero positive number. So the expression value has to be greater than or equal to 0. If there is a plus a non-zero term, then the expression value will definitely be greater than 0. And if you don't have that plus a non-zero term, like in this case, then the expression value can be greater than or equal to 0. Okay. So this brings us to the end of this question number 11. We have found the solution of every subpart of this question. And we are having one more question, that is question number 12 of this paper, which we'll be solving in our next session. Thank you for staying with me till the end. I'm Nilanjana Sanyal and I tutor IB Math A, SL and HL students both within India and outside India. And I am starting my online tutoring sessions, math online tutoring sessions, group sessions for IB Math A, SL and HL students. And if you are interested in joining my classes, you may contact me. You are seeing my email ID, you are seeing my WhatsApp number, you may call me, you may mail me, you may text me, you may contact me for knowing more details, all the details of these courses. Okay, so we meet again in our next session. Till then, bye.